Good morning. So this time, finding the resultant vector using component method. So when we say component method, we're going to find out the x and y components of the given vector. So suppose we have here velocities v1, which is equal to 10 meters east, v2, 10 meters north, v3, 10 meters west, and v4, 10 meters south. So we have here our v1, which is 10 meters east, then V2, 10 meters north, then we have here our V3, 10 meters west, then we have our V4, 10 meters south. Okay, so if we're going to take a look at on this given vector diagram, this is just perfectly the same with the Cartesian plane, as well as the points or the ordered pairs. Okay, so V1 has an ordered pair positive 10 and 0 for the y component. Okay, so in here, this is just the same with the ordered pair 0 for x and the positive 10 for y. And take note that for the first quadrant, we have ordered pairs both positive. Okay, then for the second quadrant, we have negative x and we have the positive y. For the third quadrant, we have negative x and we have the negative y. So therefore, we're talking with direction now. Okay, then for the fourth quadrant, okay, we have positive x, then we have the negative y. Okay, so again, these vectors here, 10 meters east, 10 meters north, 10 meters west, and 10 meters south, are just the same with the ordered pairs 10, 0, 0, 10. Then we have here negative 10, 0, and we have here 0x negative 10 for y. Okay? Or, so shall we say that for x component, we're going to use cosine function. Then for y component, we're going to use sine function or sine theta. Okay, to check this, so we have for the x component, we have 10 meters cosine 0. Since the angle here is exactly 0, straight line, okay, 0. So 10 times cosine 0, but cosine 0 is 1. So cosine 0 is 1 times 10 is 10. Next, how about sine 0 for the y component? 10, the magnitude, 10 times sine 0. Sine 0 is 0. So 0 times 10 is 0. No more question. Next, for V2. So take note that this is right angle. This measures, or this north and the east lines are perpendicular. So therefore it measures 90 degrees. Okay, so V2 is 10 meters. Again, for cosine 90 for the angle. Cosine 90 is 0. So 10 times cosine 90 for the x component for this angle here. So cosine 90 is 0 times 10 is 0. So we have the 0 component along x. Then how about for y? So we have here sine 90. Sine 90 is 1. So 10 meters times sine 90 is 10. Okay, again, sine 90. So 10 meters times sine 90. Sine 90 is 1. 1 times 10 is 10. So therefore, for the y component, we have 10, positive 10. Next, again, for the x component, 10 meters multiplied by cosine 90. So cosine 90 is 0. So 0 times 10 is 0. Okay, next, the same with this. Okay, for V3, so we have negative for the x, negative x component. So you have negative 10 times cosine 0. Okay, straight line. So that is that measures 0 degree. Okay, so negative 10 meters times cosine 0 is negative 10 since cosine 0 is 1. Okay, next, how about for the y component? So 10 meters times sine 0. So sine 0 is again 0. So sine 0 times 10 is 0. Okay, so that is just the same with the ordered pair in the Cartesian plane or coordinate axis. Okay, next. How about this one for velocity 4? So again, this measures 90 degrees perpendicular. So 10 meters times cosine for the x component. 10 meters times cosine 0 is 0. So the x component is 0. Next, negative 10. Why is it negative 10? Why is it negative? Since it is located along negative y. So the direction is negative. So negative 10 meters times sine 90. So sine 90 is equal to 1. So negative 10 multiplied by sine 90 is negative 10 meters. So that is now our uh, x and y components of the given vectors. Okay, one more example.